Hello everyone. I welcome you all for online video tutorial by Department of Civil Engineering, Sai Vidya Institute of Technology. Myself, Professor Gautam, working as Assistant Professor in the Department of Civil Engineering. Today I am going to explain a problems on Boussinesq theory from the subject pavement design. Now let us see the problem. Here is a problem. A circular load of radius 15 centimeter with uniform contact pressure of 7 kg per centimeter square is applied on the surface of homogeneous elastic mass. Determine the vertical stress under the center of the load at a depth of 45 centimeter from the surface. Here, in order to find out vertical stress at a depth of 45 centimeter, that means from the ground surface at a depth of 45 centimeter, we need to find out what is the vertical stress is creating because of the contact pressure of 7 kg per centimeter square. So in order to solve this, we are having Boussinesq equation that is given by sigma z, that is vertical stress, is equal to P into 1 minus z cube divided by a square plus z square to the power of 3 by 2. In this problem, he had given what is P value. P stands for contact pressure, that is equal to 7 kg per centimeter square. Then A stands for it is a radius of circularly loaded area, that is equal to how much? 15 centimeter. And depth where we are going to find out the vertical stress, that is 45 centimeter. So he had given pressure, contact pressure value, P value, radius value, and depth value. So in this formula, all the data is available. P is available, Z is available, A is available, again Z is available. Substitute all data and solve for sigma Z, that is for vertical stress. After solving the equation, the answer is 1.023 kg per centimeter square. This is one way of finding vertical stress at a given depth using Boussinesq equation. And also the same can be solved by using vertical stress distribution chart. I repeat, the same problem can be solved by using vertical stress distribution chart. In order to solve by using vertical stress distribution chart, this is the procedure. First, calculate Z by A value, where Z stands for depth where we are finding the vertical stress and A stands for radius. So 45 divided by 15, that is equal to 3. And calculate R by A. Since here we are calculating exactly under the center of the load, there is no radial distance. That means if you are applying a load at this point exactly here at a depth of 45 centimeter, we are calculating the sigma Z value. Since it is exactly at the center of the point of loading, there is no radial distance. Therefore, I considered R by A is equal to 0. Now, you have to locate this Z by A and R by A values in order to get sigma Z values in the graph. How to locate? Here I am going to show. Okay. So in this graph, y-axis indicates Z by A values and x-axis indicates 100 into sigma Z by P. You can see they had given in the graph. So I repeat, y-axis indicates Z by A value and x-axis indicates 100 into sigma Z by P, and this curve indicates R by A values. Okay, now you can locate these points. So Z by A is equal to 3. You just see where the number C is there, number 3 is there. Okay, here you can see, and this has to be intersect at the point or on the curve R by A is equal to 0. So from this point, you just draw an horizontal line, and that line should be indicated on the curve R by A is equal to 0. So here you can see the first curve indicates R by A is equal to 0. Therefore, it will intersect at this point. Correct, no? From this point, you project a vertical line like this, and it should be intersect on x-axis. It may intersect somewhere at this point. Okay, so you just mark the value of that point, that is equal to 50%. Okay, so from 3, if you project like this, it is approximately intersect at this point. Correct, no? So it is approximately intersect at this point, and that value equal to how much? 15% I noted here. Therefore, x-axis indicates 100 into sigma Z by P. So that's what I had written here. So you need to calculate the sigma Z. So I just rewrite the equation. Sigma z is equal to 15 divided by 100 multiplied by 7, where here P stands for pressure. That's what I substituted here. And finally, sigma z is 1.05 kg per centimeter square. This value we obtained by solving through graph. Okay, if you use the formula, the value is 1.023. Without formula, by using the graph, the value is 1.05 kg per centimeter square. Both are nearer values. And this is how you need to solve the problem. Let us see the one more problem on Boussinesq theory. So here is the problem. A flexible pavement of thickness 48 centimeter is laid over a subgrade. A circular load of radius 16 centimeter with uniform contact pressure of 6.5 kg per centimeter square is applied. Assume homogeneous elastic single layer theory. When it is an elastic single layer theory, you have to consider that it is an Boussinesq theory. Okay, or it is the assumption made in the Boussinesq theory. That means he assumed that your flexible pavement is a single layer. Okay. Determine the deflection of the pavement surface under the center of the load. Assume elastic modulus of the subgrade as well as the pavement layer is to be 900 kg per centimeter square. In the previous problem, he asked, we need to find out vertical stress at a depth of 45 centimeter. In this problem, he is asking what is the deflection at a depth of 48 centimeter. Okay, so according to the Boussinesq, he had given the formula deflection is equal to 3pa square divided by 2e into a square plus z square to the power of 1 by 2, where p stands for contact pressure, a stands for radius, e stands for Young's modulus, and z stands for depth, where we are finding the deflection. Okay, now let us check whether this data is available in the problem or not. See, p value he has given 6.5 kg per centimeter square. Radius value he has given 16 centimeter. Depth value he has given 48 centimeter. Then E value also he has given at the end 900 kg per centimeter square. Therefore, in the formula, all the data are available. Just substitute all the data and check out what is the deflection value. Again, the same problem can be solved by using vertical deflection charter. So this is your deflection factor chart. Okay, so in this chart, how we need to work out? Again, here first you need to calculate z by a value. So z value is 48 and a value is 16 as given in the problem. Z by a is 3, and again we are finding deflection exactly at the center. There is no radial distance, therefore you can consider r by a is equal to 0. Now these 2 points you have to locate in this chart in order to get deflection value. See, in this chart, you can observe the chart in the right tab of my screen. In this chart, y-axis represents z by a values, okay, and x-axis represents deflection factor, that is f value. And in this chart, this curve represents r by a value. Okay, so I repeat, y-axis represents z by a value, x-axis represents f value, and curve represents r by a values. Okay, so now let us try to locate the points. So z by a is how much? 3. Can observe here is a point 3, correct? No. So from this point you just project a line to the curve r by a is equal to 0. So from the point 3 you just project a line, so it is intersect at this point, correct? No. Here you can say r by a is equal to 0. Again, from this point you project a vertical line and it should intersect on the x-axis. It may intersect somewhere here. So this value, so here it may intersect, correct? No. This value I noted as how much? 0.48. Okay, so now I got f is equal to 0.48. Once the f value is ready, here we are having the formula. Deflection is equal to PAF divided by E, correct? No. P he has given in the formula 6.5, that is a pressure. Radius is 16, and Young's modulus, that is elastic modulus, is how much? 900, and f value you had found from the graph is 0.48. So substitute all, you are going to get deflection value. So that is equal to 0.0554 centimeter. You can see by using the formula we had obtained it as how much? 0.0548 centimeter. If you use the graph 0.054554 centimeter, almost both are nearer values. And this is how you need to solve problem on Boussinesq theory. Either it may be chart or by using the problem. Thank you guys. I hope all of you understood today's class. We will meet in the next class with another set of problems. Thank you.